Today we are going to look at the Renin-Angiotensin-Aldosterone system, also known as RAAS. It's responsible for the regulation of sodium and fluid or water balance in the body. It increases sodium reabsorption, which is followed by water. RAAS is activated when blood pressure drops or when extracellular fluid or blood plasma levels drop. RAAS is controlled by three major hormones, which we will cover in depth: renin, angiotensin, and aldosterone, as the name states. It all starts when a drop in blood pressure or fluid volume is detected by the kidneys, which then secrete the hormone renin. Renin starts off the reactions like the hydrolysis of angiotensinogen and the release of aldosterone, but I'm getting ahead of myself. Angiotensinogen is an inactive protein in the blood that originates in the liver. Renin hydrolyzes angiotensinogen to create angiotensin-1, a shorter but still inactive protein. Angiotensin-1 is hydrolyzed, this time by angiotensin-converting enzyme, or ACE, from the lungs, creating angiotensin-2, an active protein with many functions, such as vasoconstriction or tightening of the arteries, stimulation of hypothalamic thirst center, which increases thirst and therefore fluid intake, and stimulation of aldosterone release. All of these functions promote increased blood pressure, plasma volume, and sodium retention in the body, but we still need to cover aldosterone. The adrenal gland secretes aldosterone in response to angiotensin-2, a decrease in plasma sodium levels, or an increase in plasma potassium levels. Aldosterone promotes sodium reuptake and potassium excretion in the distal tubule of the kidneys. Chloride ions are absorbed passively or freely with sodium, and water follows due to osmosis. This happens because aldosterone promotes more sodium channels, as well as more sodium-potassium pumps in the membranes. Therefore, salt and water are retained, while potassium is excreted in the urine. Blood pressure and fluid volume increases, correcting the beginning problem. When blood pressure and volume return to normal, renin is inhibited and the RAAS activity slows, promoting sodium excretion in the urine again. In conclusion, the renin-angiotensin-aldosterone system plays an important role in sodium balance and fluid balance through a tightly controlled system of hormones.